Hey guys, this is just a progress update. I've ordered my circuit breakers for the distribution board, and they have arrived. I did invest the extra money in an RCD, so that's just a plus. I may as well buy one. This I had already, but I never really had DIN rail mount circuit breakers except this one. So I want to get everything new. Slowly. So again, money wise, I also don't have a car either, so it's kind of difficult to get distribution boards and circuit breakers down 30 kilometers while catching trains and buses. Anyway, enough of that. I've got my schematic here, whatever it's called, here for the distribution board. It's actually stapled to a separate schematic. I have made some changes though, so here it is. So this is just a distribution board. There's a green lamp and a red lamp on top, neutral and earth bus bar, my circuit breakers, RCD, main relay, 10 amp MCB, whatever, transformers, contactors, and these are just wires feeding all the the circuits. So that's transformer 1, which is the isolation transformer. T2 is the other transformer that I've got. AOX is the socket outlet. The heat is just a socket outlet for a heater. Iron means soldering iron, and lamp is just lamp. Yeah, and all these are via a switch, as these are as well, but I just haven't got the room to make all these big diagrams, I've got only A4 paper. This is what's going to be on the door of the switchboard. Big main switch there, line in, line out, ammeter, voltmeter, power factor meter, that's not going to happen, and hertz meter. There will be a hertz meter and a volt and amp meter. There will be a thermostat for the heater. So this is what the front panel is going to look like. The switches controlling everything, thermostat, emergency stop button, meters, and main switch just up there. But this is what it's going to look from behind. So the emergency stop, just controlling everything, mainly controlling a contactor. So that's quite cool. Anyway, that's what's happening for this one. I'll see if I can find... What's this? Oh yeah, this is how the contactors are going to be wired up and shit like that. So, yeah, this is kind of a mess, but the bulb goes across the line, so when I actually plug in the distribution board, that bulb lights up. The red lamp lights up once the 25 amp relay is activated. 10 amp MCB is feeding the 3 transformers to power the contactors. The 16 amp MCB goes to the contactor to T1. The 16 amp MCB goes to T2, goes to AUX, sorry, which is the auxiliary power outlet, and the 10 amp MCB goes to T2. And 6 amp and the other 6 amp MCB and the 10 amp one, they go to different things, like soldering iron and a lamp. Okay, so here are the MCBs here. So this is your main RCD, 40 amp, 30 milliamp tripping. Yeah, so this doesn't trip. It's just an RCD. No overcurrent capabilities. These are just your regular MCBs. Here's a 10 amp C-type. I'm not sponsored by these brands or any brand I state in this video or take footage of this video. They don't sponsor me, I just bought them. Anyway, it doesn't matter. So 10 amp is for the heater. Another 10 amp is for the soldering iron. A 20 amp is the main breaker, so if something goes wrong, the main one will just trip. The 10 amp is for something else. I think that's for, so I mentioned lamp. Oh no, that'd be lamp, soldering iron, heater, main. What else is there? There's 216. So yep, AUX and T1. That's for the transformers, and yeah, the other one of these is for T2. Anyway, I'll figure it out. I do, as you see, I have the diagram, and these are all DIN rail mounts, so they can go off to the side there. As you saw from last video, just the switch, soldering iron, heater, 2 kilowatt maximum, lamp, T1, T2, and AUX. So these three are controlled by, these three switches are low voltage, 12 volt, and these three are just mains. Kind of dodgy, but oh well, it's my build. I also have another build. Oh, I also got myself a new multimeter. Nice one. From Digitech, it's one of these J-Car ones, but quite nice. I do like it. It's got a thermocouple there. Here we have it here. Off, volt, AC, DC. Can also press Hertz. I don't know why it's doing that. That's really odd. And that's doing that. I don't know why it's doing that. It shouldn't be. Anyway, mega ohms, diode test. That's the ohms, just for it makes a sound when you have 0 ohms. That's capacitance, and that's back to ohms. That's temperature, Fahrenheit, Celsius, centigrade. Amps on the clamp, DC, 40 amp DC, 400 amp DC, 40 amp AC, and 400 amp AC. It's got a hold feature. It's got a relative. But yeah, that's what I have. It's quite nice. I think it needs a bit of work for the Hertz thing, but oh well. Anyway, I've got my Variac up here I need to fix because that's broken and needs new brushes, and it's also kind of stuffed at the moment. The heater. Okay, just that's cable. It's not live. Don't worry for those safety retards out there. So right, this is part of a new build that I am currently in practice of. So these are all soldered on and heat shrinked, so that the mains goes into there via a fuse and a switch, and that's going to power up my lab bench power supply that I'm currently building. Okay, so it's going to be a screen there. There's no analog meters, sadly, because they're just annoying, and I can't be bothered building it all analog. But these are that's an AC side, DC side, and that's a panel thing. I'll show you guys up here. This is its transformer, nice sonar. Don't worry about the transformer. That's my 35 amp rectifier that can have 400 amps overload for a very short period of time, 400 amp surge with lugs on it, and that's bolted down to a heatsink, and that's going to bolt to the metal enclosure. Anyway, I prefer to have a heatsink than bolted to a metal enclosure. This is the brains of it all. HDXFH, I would have to say I got the idea from, because he built something like this. It's quite nice what he built, but I saw the thing and I was like, I may as well get one of these too, since I can't really be bothered building a full lab bench power supply. It's just, this is the brains of it all. This controls, so input direct current up to 60 volts, and it variates the output current and voltage, and also power. And it's got 2 leads going to a screen. This little chip here cost me around 30 something off eBay. Oh no, not eBay, AliExpress. Okay, so this wire here connects to that little thing down there. That little thing down there, and that goes to a USB module, which you can plug it into your computer and you can see really everything. This is this is the screen, so you've got the adjustment knob, on off switch, volts, set, amp, set, blah 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 blah. There will be another video, and that little panel will be right here. I'll just be controlling it from up there. There'll probably be some switches and maybe a fuse there. Actually, I do need to put a fuse in. It's naughty me. These are just my crimp connectors here on there nicely. And I put some screws under there because this did not come with screws, but it came with threaded plastic inserts. So I will just screw that down to the metal base, the enclosure, and these connect to that. So yeah, that's my power supply build that I'm currently doing, but I need to drill out holes, and I was going to use this, but it's plastic and it's flimsy and I don't like it, so I stopped. Okay, let's take this module here, put it up there. Got myself the bulbs for the big switchboard for the on and off. Rolls of cable, and that's its instruction manual. Yeah, so that's a nice J-car bag. Just a second. Anyway, right, in here is the lovely jubbly thermostat that's going to go onto the switchboard. It's an old one, very nice one. Got some capacitors here for power factor correction. These are my big contactors with the crimp connectors on the A1 and A2 terminals to get it going. This is a timer that I might install later, and those are the 3 transformers. 2 secondary coils, 50 volt amp each. These require 70 volt amp to fully close. So if I put 2 secondaries in parallel, I'll get 100 volt amps, which would nicely get that contactor going. I've got some bus bar for the switchboard that will just bolt down onto it. The switchboard is plastic, so I don't need to earth it. This is my oh yeah, you guys have probably seen this, but the emergency stop button. Oh, that's a socket, that's a plug there. So yeah, yeah, these are the other contactors, the crimp connectors on them. This is just all crimp connectors, manual for the clamp meter, cord clamps, soldering iron, heat shrink, my toolbox, which isn't very nice at the moment, and that meter can go back into there, and these are just meters I need to service. These can go back into there, just in there. So yeah, that's about it for today. This is just, yeah, the top shelf full of wires. I got myself, oh wow, we're low on voltage today. 222. What else am I drawing? 2.9, yeah, that's all good. That's from the heater. There we go, all good. Yeah, it's around, what time is it tonight? It's around 6:38. So, all the Kiwis are having their dinners and turning on their ranges and whatever they're doing in their houses, so that's obviously putting a load on the grid. Anyway, the lowest I've seen that go is to, oh shit, 220 actually. That's the lowest I've seen that go to. Anyway, that's it for today really, guys. That's the power supply, parts of the power supply. And I'm going to do a separate video on that Variac. Oh yeah, that's the one that I said, help, my Variac needs rewiring. But yeah, I'm going to get to that and put a nice little box up here or up there just so I can control it. So yeah, that's about it, you guys, for today. So Until next time, thank you for watching.